In section 7.2, we're going to use the converse of the Pythagorean theorem. So just keep in mind you can only use the Pythagorean theorem with right triangles. So again, here's theorem 7.2, the converse of the Pythagorean theorem. If the square of the length of the longest side of a triangle, so like the hypotenuse, is equal to the sum of the squares of the lengths of the other two sides, then the triangle is a right triangle. So you can actually use the Pythagorean theorem to prove or disprove if something is a right triangle. So if c squared really is equal to a squared plus b squared, then you can conclude that triangle ABC is a right triangle. So let's see this converse put to use. Here's example number 1. Tell whether the given triangle is a right triangle. So part A, it again wants you to take the longest side, which in this case is 23, and see if that number squared is equal to the two other sides squared and added together. So we're going to take 11 and square it, add to it 20 squared, and we're going to check, is that equal to 23 squared? Punching that into my calculator, I get 521 on the left and 529 on the right. Those are not equal, so I can state now that it is not a right triangle. Let's move on to part B. So again, we're going to have to figure out what side is the longest. Is the 10 side the longest, or is 2 square root of 41 the longest? So what we're going to do is just take 2 times the square root of 41 to get a decimal approximation of what that side length would be. So again, 2 times the square root of 41 is about 12.8. So we are going to check to see if this is the hypotenuse, are these two sides the legs, making this a right triangle using the Pythagorean theorem. So we're going to take the two smaller sides, 8, square it, plus 10, square it, and see, is that equal to 2 times the square root of 41 squared. So punching in the left side into my calculator, I would get 164. And then using what we know about squaring square roots, I would need to square the 2, and I also need to square the square root of 41. So 2 squared is 4. And then if I square a square root, that pretty much just cancels each other out. So I would end up just taking 4 times 41. 4 times 41 is 164. So since I did get 164 on both sides, then I can conclude that this is a right triangle. Next, we have 2 more theorems, and I also included a theorem from chapter 5 just as a reminder. So let's first go through theorem 7.3. If the square of the length of the longest side of a triangle, so in this case it would be side C, is less than the sum of the squares of the lengths of the other two sides, so a squared plus b squared, then the triangle is acute. So again, if you take the longest side and square it, and that is less than the two other sides squared and added together, then you have an acute triangle. Theorem 7.4, if you square the length of the longest side of a triangle, so again the C, and it is greater than the sum of the squares of the two other sides added together, then the triangle is obtuse. So once again, if c squared is greater than a squared plus b squared, then you have an obtuse triangle. And then finally, again, I just put a reminder of the triangle inequality theorem from chapter 5. It states the sum of the lengths of any two sides of a triangle is greater than the length of the third side. So if I were to take the length of AB and add it to the length of BC, that sum should be bigger than AC. If I were to take BC plus AC, that sum should be bigger than AB. And then finally, if I took AB and added to AC, that should be bigger than BC. So just keep that in mind, because sometimes you may end up with 3 lengths that won't even make a triangle at all. So it wouldn't even be acute or obtuse since it doesn't make a triangle at all. Let's put these theorems to use in the next example. So here's example number 2. Can segments with lengths of 11.2 inches, 6.5 inches, and 7.1 inches form a triangle? If so, would the triangle be acute, right, or obtuse? So again, we're going to use the triangle inequality theorem to check to see if these 3 sides would make a triangle at all. If they don't make a triangle, then there's no sense in checking to see if it's acute, right, or obtuse. So what we're going to do is take 11.2, add it to 6.5, and see, is that bigger than 7.1? And it is. So now I'll do 11.2 plus 7.1. Is that bigger than 6.5? Yep, of course it is. And then finally we'll take 6.5 plus 7.1 and check, is that bigger than 11.2? Since 6 plus 7 is bigger than 11, I would assume that 6.5 plus 7.1 is bigger than 11. So therefore, this does make a triangle. So now let's see if it's acute, right, or obtuse. So we need to start by identifying the biggest side, which is 11.2. If I square that side, we're going to see, is it equal to, like we need to see, is it bigger than, less than, or equal to the other two sides added together after you square them. So 6.5 squared plus 7.1 squared. 11.2 squared is 125.44. And again, I'm going to check to see what it is compared to the other side. So 6.5 squared plus 7.1 squared is 92.66. So therefore, the c squared was bigger than the sum of the other two sides squared. So therefore, this is an obtuse triangle. A couple tips here, always make sure you start off with the biggest side on the left-hand side of your equation that you're setting up, because then if it's greater than, it's obtuse, if it's less than, it's acute, if it's equal to, it's right. But again, always start with the c squared, the biggest side squared, and that'll help you decide whether it's going to be obtuse, acute, or right. So now I've just provided you with this last slide, just a summary of all of the methods for classifying a triangle by angles using its side lengths. So again, it's just summarizing, if you take c squared and it is equal to a squared plus b squared, then you have a right triangle. If your c squared is less than your a squared plus b squared, then it's an acute triangle. And if your c squared is greater than your a squared plus b squared, then it's obtuse triangle. So this would be a really good slide to print out and tape into your notes come test time. So that's it for this section. Jot down anything you don't understand that we can go over in class, and we'll see you then.